Well, thank you. Thanks for coming to this session. I'm going to talk about VMware blockchain. The first thing I want to ask all of you is how many of you just graduated from university? Yeah? So mostly mid-career, right? Okay. But how many of you have been enraged with the college admissions scandal? Yeah, I'm enraged. I have very young kids, 5 and 8, but that really enraged me, and I want all of you to think about how blockchain could have solved that problem. And whoever gets me an answer, well, actually 2 people, I'll give away a free copy of my book. So I'm waiting to have a good discussion on that. So after my presentation, tell me how you think we could have solved this. We could have prevented the college business, the admission scandal from happening if we had blockchain. So I want all of you to think about it. So I am engineering leader at VMware. I run the engineering team there. I'm also an author of a book called Nevertheless She Persisted, True Stories of Women Leaders in Tech. I'm passionate about diversity and inclusion in tech. And the idea of writing this book was to create a lot of role models to make things possible for young girls and women to want to come into STEM and be leaders in tech, because we can. And most importantly, I am a mother of 3 kids. I have an 8-year-old boy and 5-year-old twins, boy-girl twins. So I don't do it all, but I just want to tell you that, you can do some of it. So blockchain, and I will talk about blockchain a lot, and I will talk about trust of data. That's what blockchain is. Amanda talked about data, right? It was a very enlightening talk because there's tons and tons and tons of data out there. But can you trust that data? And what blockchain allows you to do is be able to trust that data. Now, the way you can trust that data is not centralized trust. It's actually decentralized trust. So I'll talk about what that means. So if you look at a database is centralized, right? So you have a centralized source of truth, but you don't own that data, and you don't know if you can trust that data, because someone else is responsible for this data. They're modifying this data, and you're not. The other thing with databases is that you can put in a record which says Pratima works at VMware, right? And so there's a record in the system. Now I go find another job. Say I go to Facebook. What you'll do is you'll go into the database and say, now Pratima works at Facebook. But with blockchain, you don't do that. What you do with blockchain is it is an append-only log. So you basically go in there and say, Pratima works at VMware, and then Pratima now works at Facebook. So what you can do is it gives you a history of transactions. It gives you some auditability. And so this is my first clue on solving that college business scandal, right? So think about it. So blockchain gives you decentralized trust, which is very important. If there's one thing that I want you to walk away with, is decentralized trust. So there's no central authority that is holding on to your data. There's no central authority that you have to trust. Everyone gets a copy of this data, and all of you can trust that data. So what does blockchain really promise you to do? Well, if you want to become a billionaire, sure, go buy Bitcoin, whatever, right? Get into that lottery system and become a billionaire. Or you could just write a white paper tonight, because we're all smart people here in this room, and we can go start an ICO tomorrow. But that's not what VMware blockchain promises to do. And blockchain doesn't solve world hunger, and it doesn't solve everything. Amanda talked about, all these use cases that she had for machine learning. Blockchain is not like that. Blockchain solves very specific use cases, and we'll jump into those use cases. So if someone comes and says, oh, I want to do blockchain for this, or blockchain for that, it has to be a viable use case. And what we've done is we've talked to tons of partners and tons of customers, and we've actually nailed it down to 4 solid use cases where blockchain will really help. So going back again, it's giving everyone the same trust of data, which is decentralized trust. And I'll keep talking about this as we go along in the presentation. So that's the key of it. So this is the same thing. It basically says, everyone gets the same copy of data that they can trust. So the 4 use cases, I'll start with the first one. This is guaranteed and verified data dissemination. So this is your second clue on how to solve the college admissions scandal. Because every institution will have a copy of data. So for instance, disease reporting. So there's a new disease that crops up. What you can do is put that data into your blockchain, and all the institutions that need to know about this, all the regulators and auditors, whoever, they can get access to the same copy of data. And so they will know if there's going to be an outbreak or not. So that way they can prevent anything that can happen, in society. So that, I think, is impactful. But think about it also in terms of the business scandal, because you've got incentives here. The second is asset and product tracking. I like this. I love drinking beer. Who likes beer? Right? There is a lot of fraud in this world, right? So what happens is the beer that you're drinking may not be the beer that actually came from the company you think made the beer. So from the manufacturing process to the consumer, you don't know the product that you're consuming actually came from that particular brand. And so blockchain will help you do that. So it'll actually track your product. So it'll basically say, okay, this beer got manufactured by Heineken. It went to this retailer, distributor, and then a supplier, and then it finally got to a liquor store, right? And so you can have an application, a blockchain application on your phone. So while you're sitting and drinking beer on a Friday night, you can basically scan your beer, and it'll tell you exactly where your beer came from. Isn't that cool? There's actually a restaurant down in Palo Alto called Counter. If you go eat there, they'll say, I don't quite personally like that, but they'll say, oh, this burger you're eating came from this cow, Amy. And I'm going like, I really don't want to know, right? Like I'm eating Amy right now. You know what I mean? But you have that power, right? You have that power. As a consumer, you have that power in your hands, which is fascinating. And so that's why I think blockchain can change the world in how we transact between each other. Asset transfers. So asset transfer is, I'll give you an example. So the way we do asset transfers right now is we write things like smart contracts. So smart contracts are just programs that get written onto your blockchain, and they get executed. So you could write a program saying something like, and I'll use Alice and Bob because we like Alice and Bob. So Alice wants to sell a couch for $300. Now Bob comes in, and so there's a smart contract that basically says if somebody pays Alice greater than $300, we sell the couch. If not, we don't sell the couch. Now Bob comes in and he says, you know what, I can pay $310 for this couch. So once he comes in and says, I want to pay Alice $310, this contract will get executed on the blockchain. And the transaction will get persisted in the blockchain, right? So now Alice can't sell the couch to Bob and then go and sell the couch to someone else, right? So this double spending problem doesn't exist in a blockchain. So that is very critical. So a lot of Bitcoin today also solves that problem. It solves the double spending problem. And so this is very crucial in terms of blockchain, because now you can trust that transaction. You can trust that you are getting that couch. And it's not like this couch was promised to someone else, and this person's not going to come knocking on your door and saying, hey, you know what, Alice just sold me that couch, and now that's my couch, right? So it prevents things like that with some of the use cases that we can have for blockchain. So asset transfer is one of those things where you can programmatically write these smart contracts, and they'll get executed on your blockchain. Certified claims. So this is my third hint, perhaps, or my fourth, I'm forgetting. But what you can do here is you can basically do background checks. You can actually go in and, call, say if I went to Harvard and I got, a hand-weaving basket degree, right? Someone calls in and says, did Pratima get this degree? And then Harvard can say, yeah, she did, or no, she didn't. She got a degree in advanced pet sitting. I'm sure there's degrees like that at Harvard. And so there's fraud involved in that, right? And instead of everyone calling Harvard and saying, oh, did Pratima graduate from this place? And Harvard's like, no, she never graduated, or she did graduate. Or like 20 or 30 people calling Harvard. Harvard can keep that data, which you can just go and look that up and say, oh, in like a second, you can say, oh, you can verify that. You can say, oh, did Pratima go to Harvard and get this degree? And you'll know right away. So if you look at a lot of the background checks that we do, and I'm a hiring manager at VMware, and in my 20 years, I actually haven't seen a lot of background checks fail, but I recently had one. There was this one candidate who said he graduated from a particular university, and he didn't. And we didn't know, right? But it was through backdoor reference checks. I don't know what it was. I was sitting at the Singapore airport, and we said, oh, we're giving an offer to this person. And I said, out of a whim, I said, can we do some backdoor reference checks? And they said, sure, let's go ahead and do that. And then it got an email like 48 hours later saying that he actually lied. And he didn't actually go to the university he said he did. And you won't believe there are many cases like that, right? So I know it's shocking to us, but it happens, and it happens in sheer numbers. And blockchain will actually prevent that. So VMware is looking into certain areas where blockchain can be viable. One is the supply chain use case, and all of you should be familiar with this. Though it sounds very enterprisey, but in some ways it actually impacts all of us, right? So you go from a producer, like say, you're getting your fruits from some farmer, right? They're the producer. It goes to a processor that actually processes these oranges or whatever, or fruit that you're getting, and then it goes to the wholesaler, the distributor, and then finally it comes to you as a consumer. And the 4 use cases that I talked about was product tracking. So this is where the consumer says, okay, you know what, I ordered a basket of oranges from your store, from this farmer. Where is it, right? So you're actually trying to track your product that way. And then your producer sends you, all these coupons and whatever, right? That's data dissemination, distribution in some sense, or recall information like, don't eat those oranges. No, I'm kidding. Or something like that, right? So they're the ones who are giving you all this information. And then you have asset transfers where this particular asset is getting transferred from, say, a processor to a wholesaler to a distributor. And you also have a way for a distributor to go and actually verify and do a lot of inventory checks on that particular asset. So if you look at a supply chain use case, blockchain is fantastic here because it takes those 4 use cases and it actually puts it through this entire supply chain use case. Similarly, we can use blockchain in financial services where, if you're doing a stock exchange, you're buying and trading and selling stocks. There's one way of doing it because that, again, is some form of an asset transfer, right? And you want it to be verifiable and trustable, and you want to have integrity of that data. So blockchain is very, very powerful in financial services as well as in your supply chain use cases. And that's kind of where VMware is totally focused on and targeted. I do want to tell you that what we're doing is private and permission blockchains. What Bitcoin does is public blockchains. What I mean by that is you can actually today go and get a Bitcoin node. You can get an Ethereum node on your laptop. And no one knows who you are. And actually all of us in this room can go do it, right? So that's a public blockchain. And what VMware is implementing is a permissioned private blockchain where we trust you. We know who you are. So you're part of some consortium. And then you get invited to this particular consortium. So we know who you are. And so that way we have some level of, some form of an identity as to who you are, and we can trust you. So it kind of goes against the public blockchain model where you're anonymous in some sense. But here, we know who you are, and we know we can trust you, but we don't know anything more than that, right? We don't know your name and where you live and all that, but we know you are a trusted party, and we know that we've invited you to this network, and so we can trust you. So VMware's blockchain is basically 3 pillars right now that we're looking at. We open sourced an infrastructure called Concord, which basically uses an algorithm called Scalable Byzantine Fault Tolerance. How many of you have heard of BFT? Okay. So in the olden days, we used to have these Byzantine generals. So Byzantine basically means malicious. And so you had, like, say, 3 generals that are trying to attack a city. And they would have to send messages. They didn't have cell phones like we do. And so they would have to send messages to each other basically saying, hey, I think we can attack at 4 a.m. in the morning or we'd retreat. And what the generals would do is they would send messengers on a horse. And so this person on a horse would go to the other general and say, oh, we're going to attack, right? But somebody can actually kidnap this messenger, right? Or they could impersonate this messenger. So every time you get a message, you don't know if you can attack or you have to retreat. So the SBFT model basically says is if you have 2/3 consensus, then you can trust it. You can tolerate up to 1/3 of malicious actors in a particular network that you can trust the data. And so that's what Concord does today. So it basically runs by this formula called 3F+1, where F is the number of malicious nodes VMware infrastructure can tolerate to the point where then we can say, you know what, you can trust this data, there's liveness in this data, there's integrity in this data, and you can trust this data. So if you basically say, I can tolerate 2 malicious nodes, then your formula is going to be 7, right? So you can have 7 nodes, Concord nodes in your blockchain nodes, which are your blockchain nodes, in the system, and you can tolerate 2 malicious nodes. Now, if you have more than 2 malicious nodes, you're host. You can't trust that data. But based on that formula, you can basically say, you know what, I can tolerate 2 malicious nodes, and I can go with a 7-node configuration. So that's what Project Concord does.
Is Byzantine a microaggression?
Is the what? I'm sorry?
Is Byzantine a microaggression?
No, I'm not sure about that.
Just because Byzantine is what is now Istanbul, so Turkish.
Perhaps, yes. I should go look. That's an interesting thing. You'll get a copy of my book. I'll go look it up. The second thing we want to do is, the other thing we want to do is we want to make this enterprise-grade decentralized trust. What we mean by that is we want to be able to scale a lot of the nodes. If you look at Bitcoin today, they can, there's a concept called time to finality, which means the time it takes for your transactions to get persisted on the ledger. And Bitcoin is around, I think, around 6 to 10 transactions per second. Ethereum's around 15, which means that you can't use it when you're doing Christmas shopping, right? Because we're all charging our cards. And imagine if it took 10 transactions per second, we'd be getting nowhere. So if you look at Visa, they process 10,000 transactions per second. I think PayPal does 1,000, 2,000 transactions per second. And VMware is trying to get to that level, right? So right now we do, with what we've built, we can transact around 445 transactions per second. So we're trying to optimize our platform to make it enterprise ready. We won't be, most enterprise use cases don't require that level of throughput. But if you look at financial services, when people are trading stocks, the throughputs are a lot higher. So we want to make sure that we can actually scale and we can get to that throughput to that grade. So the thing that we're doing right now is trying to get to this enterprise grade decentralized trust. The other thing is, robust day 2 operations. What that means is you first come in, you say, you know what, I want a 7-node blockchain. We install it for you, and then you go away. But then day 2 operations is being able to monitor it and debug it, manage the life cycle of some of these blockchain nodes in the system, so that becomes a critical thing. So VMware is doing that. The third thing that we're trying very hard, and this is the fun part for me, is making it developer friendly. So what that means is getting these developers, like smart contract developers, which I think is a great area for you all of you to look into, is being able to write these smart contracts that you can persist on the ledger, right? So what we support is we support Ethereum virtual machine, where you can actually go write Solidity contracts on this and persist it in the blockchain. And it's almost like JavaScript. If you know JavaScript, Solidity is, it's got promises and all those things that JavaScript has, and it's very familiar. So you can actually go off and write these smart contracts on your system. So what VMware's challenge, or what I see as a challenge, is we can do the first 2, we're great at it. The third is trying to build this ecosystem of developers to build a lot of use cases on your platform. And that's why we do a lot of hackathons. We try to attract a lot of developers who can come and build these smart contracts on your platform. So Project Concord is open source, so it's out there. It's all in C++. You can go get it, download it, run a node on your machine, and you can start writing smart contracts. You can deploy it. You can look at the transactions. Yay, right? What we've done is VMware is a very green company. It's one of the things I really like about working there. And if you look at Bitcoin, if you transact Bitcoin, any of you mined any Bitcoins? Okay. So when you mine a Bitcoin, the resources it takes to mine that Bitcoin can power Ireland. That's how much resources we use to mine one Bitcoin. So it's a lot of resources that we use. And that's why, people can't afford it. And so you have these mining groups, and you have, in Bitcoin you have, like a huge, large sum of people who can afford it and who can afford these resources, who are constantly mining, so they have the power. And so what VMware basically decided is, this is, actually Pat Gelsinger, our CEO, basically said it's immoral. He said these blockchains today that exist are immoral. And he was very clear. He wanted us to build an energy-efficient platform. And so with SBFT, that's what we built. And if you actually go into the technical details of SBFT, the way we do that is we tweaked this algorithm called PBFT, where the communications between all the nodes was exponential. And what we did with our innovation team, our research team, was the communications between our nodes is now linear because we use this concept of collectors. So you have these collectors in the system that actually take the messages that the nodes send it and then send it to the client, which is your smart contract or your decentralized application. And so what we've done is we've gone from an exponential algorithm to a linear algorithm, which really simplified our energy efficiency. And so we're really, really proud of it. And we also figured out some smart ways of being able to persist our transactions faster than EVM. So that's why our throughput's a lot higher than Ethereum virtual machine if you look at it today. The other thing we've done, and this is a differentiator for us, is we don't want to lock ourselves into a single cloud provider. What that means is we want to be able to run this infrastructure on multi-cloud. Because when you go to customers and you talk to customers today, they're not tied to one cloud. They don't just have Azure or Amazon, right? Or Google Cloud. They have all three clouds running in their business. And so we don't want to lock our customers to a single cloud provider. So our differentiation story is basically saying you can have these clouds you can have these blockchain nodes on these different clouds. And I talked about better scaling and throughput, where we really want to make sure that we want to get to high scale. One of the things that is going to take a very long time for blockchain to become mature is actually scaling and throughput. That's a big one, because the existing platforms today don't have that. We don't have standards around it. So there's a lot of work that needs to happen with enterprise businesses before we can get to a production-ready blockchain. So if you hear someone saying, hey, we're in production on blockchain, don't believe them. Because even we're not in production, we're like in beta. Because it's very hard to get to that scaling and throughput, and everyone's trying to work towards that. And this could be, I don't know how long it'll take, but it's going to take some time. The languages we support are Ethereum virtual machine. We support something called Hyperledger. And we recently signed a contract with this company called Digital Assets, and we support the DAML language. So it's Digital Assets Modeling Language. I don't know if any of you are familiar with EVM and Hyperledger that's out there in the market today. Okay. So we'll start with how Bitcoin started, right? Satoshi, I actually have a T-shirt that says Satoshi's female. It bugs everyone. Because we don't know. Everyone says he, and I'm like, what? Could be a woman, right? And maybe it was a woman who basically didn't want to say she was a woman because then the world wouldn't take her seriously, right? So Satoshi went off and created pretty much blockchain for Bitcoin. And Bitcoin was one of the first use cases for it. And then Ethereum came along, where basically Ethereum came and said, oh, that's great. We'll build smart contracts. We'll make it programmatic. So they went off and they built smart contracts. Then Hyperledger came in and basically said, hey, we want to be the first enterprise platform, and so they went off, and they basically said, you don't have to do Solidity or anything. You can write Java code. So that's their thing. So they call it chain code. So you can write it in any language, and it'll work on Hyperledger. And there's a lot of effort happening in the Hyperledger community and the EVM community to get to scaling and throughput. But they have a lot of problems in terms of, just their time to finality, their scaling throughput. And so we went off with really smart researchers, and we built Project Concord. So I have like 5 minutes, you said? Okay, so our core is, Project Concord. That's basically our infrastructure. We want to build a lot of utilities around it, things like key management, zero-knowledge proofs, identity management, so people know who you are, and multi-blockchain is going across these different blockchains like EVM and Hyperledger and all these other things. And on top of that, we want to build these blockchain apps. So this is where I'll stop, because I want a conversation, and I want you to think about, how do you think blockchain could have solved this college admission scandal, if it existed and if it was in production? Yes.
They're recording it, so they want.
Blockchain might have solved the scandal if from beginning to end, everything could have been documented. The whole process, when the student, all the students' information, and if everything was decentralized, if everybody had access to that information about the student, the corruption would be minimized. People, I'm sorry, I'm not being very articulate, but everything would be clear, and the certification for whether the student was on the football team and a football team existed in that high school would be made clear or not. And I'm sure like all the financial transactions would be accessible to anybody to see. So corruption would be handled that way. And the student's history would be easily searchable as well.
Yeah, that's a great one. Like, you could just go and see if that person was part of the crew team. Now, could Rich Singer could have called the coach and said, I'll give you $500,000, just enter her name in the ledger? Can someone answer that?
So I like the idea you mentioned before, the 3F+1, right? So now it makes it more difficult. So you can't just have one person pretending and saying, oh, I validated it. You have to have 3F+1. And so now you have to have multiple people. So you'd have to bribe, instead of one person, now it's like, 5 people or 7 people.
Awesome.
And it gets more difficult.
Yes. So that was the point I'm trying to make, is you need consensus. So Rich Singer couldn't have just called the coach and said, dude, I'll give you $500,000, put her name into the blockchain, because he would have had to call, like it had to be a consensus. Yeah. Very cool.
That 3F+1 that you were saying, it's called a quorum.
Yes.
So you have at least these many number of people before you can take a decision on something and accept it as true.
Yeah. Yeah. It's very cool. I hope you like blockchain now. And
Essentially just check the veracity of the claims on the transcript,
yeah.
CD or whatever it is.
Right.
But is there any other way to manage or verify any of the other participants in the scandal?
You mean the malicious?
You mentioned money, for example. It'd be very hard, I think, to track that, unless you're really mining deep into a recipient's bank account and saw, an untraceable amount of money or something like that.
So you're saying like tracking the malicious people's money?
I'm just asking
Yeah.
I thought that was a great response. Those two were great.
Yeah, that was a great response, because she was basically saying you need consensus to even put that. So it won't even be a transaction in the
Right,
blockchain.
I'm saying, have you thought of other possible things?
Of where you could game the system?
No, where you could add accountability so that the system couldn't be gamed.
Yeah, so the thing is, we didn't get into the technical guts of how this all works, right? So there's encryption, there's a deep cryptography, right? There's a lot of things. I mean, there's SHA-256. It's very hard with the hashes that you build onto the blockchain. It'll take trillions and trillions of years for even a computer system to break it, right? So we have very strong cryptographic measures in the blockchain itself. So it's very trusted. So in that sense, you can trust that data, right? There are things like zero-knowledge proofs, and I didn't talk about it, it's pretty much saying, I have this clicker, I can hide it here. I can basically say I have this clicker, but you don't know I have this clicker, and I can show you that I have this clicker by moving the slides, right? So you know that I have something that's doing it, but you don't know exactly what I have, right? That is zero-knowledge proof. It's basically saying, I am who I am, but I can verify it, but you don't know who I am, right? So in terms of privacy, like Amanda was saying about having your data out in the open, I actually hate that. I don't want people to know my food habits and all that stuff, right? So with blockchain, it basically says, oh, I know who you are, but I can trust who you are, but I don't know who you exactly are. And so there's a lot of research that needs to happen with zero-knowledge proofs that VMware is actually doing right now, so we could build that level of privacy into blockchain, which I think is amazing. It gives me goosebumps. But what I wanted with this talk for you guys is to go off and really know that blockchain impacts all of you. And it is a very interesting technology that you should learn and read about. And I'm hiring. I want women on my team. I have a lot of white dudes, which is not bad. But, I want diversity in my team. I wrote an entire book on diversity, so please ping me on LinkedIn. We're doing some amazing, amazing stuff at VMware, and we want to change the world. The crazy people want to change the world, and they're the ones who change the world. So thank you for being here. And I feel bad. I want to give away 3 books, but I have only 2. Okay, I'll give it to you guys. I want to sign it, though. I haven't signed it. I haven't signed it because I wasn't sure who was going to give the book away to. So, yeah, she's just reading it. Awesome. Thank you.